Good evening, everyone. In the last videos, we discussed very clearly about backtracking, what is mean by backtracking, and how we can apply this backtracking technique. Okay. Next and after that, backtracking with arrays, how you can able to retrieve the values one by one. Next and after that, how to find subsets by using this backtracking, and even how to find the permutations and the combinations. Okay, by using this backtracking, we have seen very clearly in our last videos. Now we need to talk about n queens problem. Okay, sir, what is this n queens problem? Already we discussed about this problem in the last video. I think a simple example I have given. Sir, we have to place n queens. Okay, yeah, continuation of special class. So we have n queens. We have to place n queens on n by n chessboard. We have to place these n queens on n by n chessboard, such that no two queens, okay, can attack. Okay, can attack each other. Like this, we have to implement. Okay. I think rather than problem statement, if you explain with the help of a diagram, it will be very good for you to understand. Sir, already I explained, right? For example, if you take a 4 by 4 chessboard, just for our understanding purpose, I am taking a 4 by 4 chessboard, sir. Like this, we have 4 rows and then 4 columns. This is nothing but a first row. This is nothing but, I think, better. Okay, this is nothing but 0th row. This is nothing but a first row. This is nothing but a second row and a third row. 0th column, first column, second column and third column, like this. Maybe for our understanding purpose, we are going to take 3 chessboards just for your understanding purpose. Okay. Now, listen carefully, friends. Sir, it is a 4 by 4 chessboard, right? It is a 4 by 4 chessboard. That means in this board, we are going to we have to place the queens. Sir, first, we know the concept already I explained in the last video. If we are placing a queen here, so what is our next step? We should not place any queen in this down arrow, in this next left arrow, in the top arrow, in the right direction. That means this queen can move in all the directions, even in the diagonal. Okay. Anyway, when we start implementing, I think we are not required to check downwards because the data is not there in the down. The data is always in the up. First queen directly we can place here. Sir, can I take second queen here? No, because collision will happen. Can I take next queen here? No, collision will happen. It will attack each other. Can I take here? Yes, no problem. Next queen, third queen, we can't take here, attack. So we can't take here. Yes, these two queens when collide. Here also we can't take. So here also we can't take. So the only possibility we have here. Now third queen, can I take here? No. Sir, can I take here? Yes, we can take. Okay. Next fourth queen, can I take here? No. 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 That means there is no proper place for fourth queen. So what we have to do? I'm going to change the position. Here it is not possible. I'm changing the position. Here also it is not possible. So this first queen placement itself is wrong. So I'm going to take here. Can I place here? No. Can I place here? No. Can I place here? No. So can I place here? Yes. Now, can I place here? Yes. Now, sir, can I place here? No. Can I place here? No. Can I place here? Yes. This is nothing but one solution. Okay. Sir, third place, suppose assume I am placing this queen in third position. Okay. Next queen, can we place here? Yes. Next queen, can we place here? No. Here, no. So here, no. Here, yes, we can place. Next queen, no. Sir, here, yes, we can place. Okay. So here we can't place and here we can't place. So this is one possibility. Okay. Sir, can we take here? Can I take here? Yes, sir. Sir, next, here we can't take, here we can't take, here we can take. Next, can I take here? No. 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 That means here we can't take. Next, backtracking here. Sir, can I take here? No. Here, no. So here, no. Here, no. So that means here. Sir, we can't take. Here, we can't take. That means there is no solution. The only possible two solutions for this 4 queens is nothing but this one, sir. Can you please confirm? Is the problem statement, is it clear for you people? Is the problem statement, is it clear for you people? Right. Slowly, I'm trying to take implementation of this program, sir. Okay. Now, listen, friends, carefully. Now, I'm taking a Java program where, okay, I want to provide n by n chessboard. So 4 n value, I'm giving 4. So character, I will take a board because in the character, I want to place which values are q, right? Q is the character. That's why I'm taking board. So what is the size of this board? New character of 4 by 4. No, better to take n by n because we can change that n value dynamically. What is the initial values? I is equal to 0, I less than board dot length, base array size it will return. Okay, base array size, because both arrays are having same dimension. That's why I'm taking base array size I plus plus. So next term, for integer j is equal to 0, j less than board dot length j plus plus. So what is the initial values board of ij is equal to, by default I am taking x. By default I am taking every element is nothing but yes, x. Now, do you know, I want to print this board as of now. So I will define, so print board function, which is going to take your board, So you have to print the content in that board. So I'm going to define the method for this public static void. I'm taking print board function. So print board, which is taking a character, okay, board like this. And I'm going to print system.out.println of array boss. This is nothing but my chessboard. This is nothing but my chessboard like this. So again, for integer I is equal to 0, I less than board dot length, okay, I plus plus. Again, for integer j is equal to 0, j less than board dot length, so j plus plus. System dot, since it is also a matrix, right? So I'm going to print a board of ij followed by some space, right? Followed by some space. After completion of every row, I am printing new line character. Simple code, 2 functions I define. Okay, as of now, the task is there. Of course, it is the easy task only, don't worry. Now, sir, I want to execute this code. Java C test.java. Java space test. Sir, it is printing a 4 by 4 chessboard, right? It is printing a 4 by 4 chessboard. Okay. Maybe it is very lengthy. No problem. You can take it for 8 by 8 so that at last you can see the full-fledged answer. Sir, we have a 4 by 4 chessboard is there. In this chessboard, we have to fill the queens. That is our task now. Okay. For that, do you know, from the main method, I'm going to call, okay, from the main method, I'm going to call n queens. So where I'm going to pass your chessboard, at the same time, what is the starting location to place the queen? Sir, first we will start attempting by placing the queen in 0th row, 0th column, right? So I'm taking row 0. Means what? Sir, first I tried here, right? So that's why I am giving this row. What is the row counter? This is 0th row. This is the first row, second row, third row. So 0th column, first column, second column, third column. I am concentrating on row. Here I will place my first column. So board of 0 I am calling. Sir, now what we have to do? We need to define that n queens, public, static, void. Since it is an array, so we are not required to return any result. So it is going to take character, so board, and integer. Which value we are going to pass? That we have to capture. Sir, which value we are passing? Very simple, sir. We are passing the value of row. Now we have to write base condition. We have to write base condition for this. Then we have to write our main logic. Main logic. In the main logic, we will have recursion and backtracking. Both will be there. So what is the task of recursion? To do this repeatedly. What is the purpose of backtracking? If solution is not found, from that it will again repeat the task. Wherever you left the solution, you are not getting. Sir, I attempted. So in that queen, is there any possibility to place in that cell? If it is unable to have the solution, from where we started, it will pick up to that point. For that purpose, I am using backtrack. Sir, this is nothing but the skeleton what we have. Can you please confirm? Is the skeleton is clear up to this? Is the skeleton is clear up to this? Please confirm, everyone. Right. Sir, what is my next requirement? Sir, can you please fill this base condition? Array boss, when you are keep on searching, your row value is there, right? If it reaches to board dot length, then can you please print that board? That's all. After that, simply return. Sir, what is this condition? Row is equal to board dot length. This is the board, right? This is the board. I filled here. 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 What about next count? It will be 4, right? Your row value is equal to what is the length of the board? 4 matrices, 4 by 4. So 4 will be there. So if it is got, then immediately we can return the solution. If you are unable to place here, okay, if you are unable to place here, so here unable to place, here unable to place, here unable to place, here unable to place. Sir, is the row value will move to the next place? No. Then backtracking will happen. Like that we are going to check. This is nothing but the base condition. Okay, it will happen only if you get the solution. Okay, fine. What is the main logic, sir? Can you please write? Because this is the very important, sir. Please listen carefully. Integer j is equal to 0, j less than board dot length j plus plus. Sir, I can say this is nothing but column loop. Sir, why you are not taking row? Because row value already you have passed 0th row. Now my task is I have to put in the columns. In which column it will be suitable? I need to traverse this entire thing. That is my main task now. So that's why I have written a loop. Now, sir, I'm going to place board of your row value is there, right? Your column value is there, right? There I will put a queen. There I will put a queen. Okay. Now, sir, in the first row, we got this queen. Okay. In the first row of, sir, here we have to take j. Okay. So in this position, it is going to put a queen. In this position, it is going to put a queen. So that means when j is equal to 0, sir, please, I request everyone to please switch off your video. Sushant. So it will put a queen here. Sushant, I request you to please switch off your video mode. So we are going to put a queen here. Next, what we have to do? J plus plus. So we have to put a queen here. Next j plus plus. You have to put a queen here. Next j plus plus. You have to put a queen here. Okay. Sir, how to jump to the next row? This is the recursion. I am passing same board by passing row plus 1. Sir, is it a recursion or not? Yes. Now what will happen? It will take next column, next row. Like that it will print. Sir, like this it is going to print. Now what will happen? Once if it is reached to the next row, my base condition satisfied, right? Then it will print. Now let me execute up to this. Sir, everywhere I got a queen, right? Everywhere I got a queen. Everywhere I got a queen. Because multiple times it is working, no problem. We have to restrict this. Don't worry. Okay. Like this, it is going to print multiple times. So this is nothing but what we have. But sir, how you are going to decide this? Because I don't want every queen. I don't want to place everywhere. I need to check the condition. What is that condition? Is safe. Is safe. Array. I have a board is there, chessboard is there. In this is the row number, this is the column number. In this particular place, is my queen is safe? Then I can able to put here. I can able to put the queen. After that, I will move to the next row. After that, I will move to the next row. That means, sir, it will check. Some assistant is there. Okay. Now I'm going to ask that assistant. Array, can you please tell, is there any possibility to take a queen here? Is it a safe place? Yes, it is the safe place as of now, right? It is the safe place as of now. No problem. You can put a queen. Next term, after this, J value will be incremented by 1 unit. Now I'm telling, I'm calling to is safe. Array, is it a safe? Since it is in the same row, we should not take, right? That's why it is going to return unsafe. Is it safe? Unsafe. Is it safe? Unsafe. So one column got completed. Then what will happen? I am calling recursion process, same board and then row plus one. Sir, it will jump to the next row. Sir, is it a safe? Safe function will return false because it is there already. In this particular column, already we have. So it won't return safe. Next, is it possibility? In the diagonal also it will check. No possibility. Sir, is there any possibility here? Yes, it will return true. Okay, fine. Is there any possibility here? No, collision will occur. Then J loop got completed. Next row it will check. Sir, is there any possibility here? No, because in the column already it is there. So is there any possibility here? No, diagonally it is going to attack. Sir, is there any possibility here? No, in the top level it is going to occur. Sir, is there any possibility here? No, here it is going to match. Sir, there is no place. There is no place. Then what will happen? Sir, the problem is safe is going to return false. Then who called this n queens? So this is the method, right? This will be backtracking. That means it will delete this and it will continue placing here. Sir, how you can able to write that? Here I am going to take board off. Board off. So your row value I am taking and your column value I am taking. There I will take X because this condition is failed. So I will replace this with X. Then where it is stopped, J value 2. It will continue from J is equal to 3. It will put here. Is there any collision? No. Then next row. Sir, is there any collision? Yes. Sir, is there any collision? No. Then, so is there any collision? No. Then is there, sorry, collision? Yes. Is there any collision? Yes. Sir, now next row. Is there any collision? Yes. 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 Then, so this value is also placing here. Sir, is there any collision by putting here? Yes. Is there any collision? Yes. Is there any collision? Yes. Is there any collision? Yes. Sir, now it will take here. Is there any collision? Yes. Backtrack. This is also wrong. So backtrack. So one more row. Now it will place here. Okay. Sir, now can we take here? No. Collision, collision, collision. Sir, yes, we can take. Can we take here? Yes. Sir, can we take here? No. Can we take here? No. Can we take here? Yes. Sir, can we take here? No. Like that, it is going to check. When it comes to the next, it will print this one, sir. It will print this one. But what is our main task, sir? Is this to place this queen in this position? Is it the safest place or not? We have to decide. So the total work is going to done by this is safe function. But don't worry, it is not that much difficult, sir. It is easy only. So Prakash sir is there. So don't worry at all. I will make this as a very simple for you people. Can you please confirm, is the working principle of this n queens function? Is it clear for you people, guys? Please respond. Clear, right? Right. Now, sir, listen carefully. Now we have to define which function, sir? Public static is safe, which will return a Boolean value, where I am going to take character, sir, your board I am passing as it is, and then row value is required. At the same time, column value is required. Now you have to check three cases. Vertical up is the one case. What is the next one? Diagonal left, diagonal left up I am going to check. What is the next one? Diagonal right up we have to check. Sir, why? Because consider I want to place a queen in this position. Just imagine in this position. Sir, where the collision is going to happen? Here there is a chance. Here there is a chance. Here there is a chance. Sir, we are not going to check here because, sir, here queen is not there. We know because we are in this position. We are checking, is it safe or not? If it is safe, we will come here, right? Okay. So if it is safe, we won't come here. Immediately we will go for next position. So that's why we are not required to check. We are not required to check this place or this place or this place or this place or this place because queens are not there. Okay, queens are not there. Once if you got this placement of this queen, then immediately what we are doing? We are moving to the next row. You can see in the code. Once if the queen got placed, immediately we are moving to the next row. If a queen is not placed, then only we will move to the next position. That's why we are not required to check these bottom cases. Only three cases. In the top column, is there any queen or not? That is called as vertical up. In this diagonal, is there any queen or not? This is called as diagonal left up. So in this diagonal, do you have any queen? This is called as diagonal right up. That's all, sir. Only three conditions. Once if I write first condition, the rest of the two things will become very easy. If these conditions are satisfied, it will return false. Okay. Now listen carefully. How I can able to check in this up diagonal? Sir, what is the position of this value? We can say it is nothing but 2, 2, right? Up means what? Here this one is nothing but what? 1, 2. Sir, in this it is 0, 2. Have you observed? Column values are same. But which value is changing? Row value. That too in which order? Decreasing order. So I am going to take for integer I is equal to row minus 1. Because we are in second row means we have to check from first row. Row minus 1. I is equal to row minus 1. I greater than or equal to 0. I minus minus. Up to top level row I am checking. What we have to do? If. Okay. So if your board of ij or because we are writing column, right? So we are changing the value of row. So column is fixed. Here. So I of column I can take, right? I of column is equal to queen. If already queen is there, boss, can you please return false? That's all. Simple logic, right? So we are checking in the top direction. Is there any queen or not? Suppose consider I want to place here. So what it is going to check? First it will check I is equal to row minus 1. What is I value? What is the row value here? It is a 2. What is the column value? 2. I is equal to row minus 1. 2 minus 1, 1. Okay. So again I value is greater than 0. That is 0. Two values we are going to get. So it will check board of. So 1 and then column value is 2. So board of 0, column value is 2. That is our requirement, right? Here we are checking, here we are checking. If already queen is there, return false. Sir, can you please confirm, is this vertical up direction checking? Is it clear for everyone? Is it clear for everyone? Right. Now, sir, we have to write code for diagonal up. Diagonal up. Now observe carefully. Diagonal up means, just for our understanding purpose, I am writing here, sir. Diagonal up means if you have a queen here, you have to check in this direction. Means what? This is 2 comma 2. This is 2 comma 2. What about this one? 2 1 0. So 0 1 2. What about this one? It will become 1 comma 1. It will become 0 comma 0. Have you observed? Since we are giving row value as a 2, column value as a 2. Sir, what is happening? Row value is decreasing, column value also decreasing, right? So 2 minus 1, 2 minus 1, 2 minus 2, 2 minus 2. Correct, right? So column values are decreasing. Here, since there is a change in only one value, that's why I have written only one loop. I mean, one condition, that is I value alone is going to change. Column is fixed. But here, row value will change, column value also will change. That's why, so I am taking two variables. Sir, what is these two variables? Integer was your I value is row minus 1, comma j value is column minus 1. Yes, we can take multiple initializations in the for loop initialization section, no problem at all. What about condition? Array, your I value should be greater than or equal to 0. At the same time, your j value also should be greater than 0. I minus minus, comma j minus minus. That's all. Sir, diagonal up left is okay. What about a diagonal up right? Right up. Sir, how you can able to check in this position? Otherwise, I will put a queen here in this position. Sir, how you can check? Sir, is it 0, 1, 2, 0, 1, 2, 3? Sir, we are at 2, comma 1, right? 2, comma 1. What about this one? Sir, 1, comma 2. What about this one? 0, comma 3. Have you observed? Sir, here 2 is there. Next value is 1. Next value is 0. Here 1 is there. Next value is 2. Next value is 3. That means what? Sir, row value is decreasing. Column value is increasing. Same loop, right? Same loop. I is equal to, I am taking row minus 1. J is equal to column plus 1. I greater than or equal to 0. So j less than board dot length. I plus plus, sorry, I minus minus, j plus plus. That's all. If this condition satisfied, false. If this condition satisfied, false. If this condition satisfied, false. Sir, it is not satisfied. It is not satisfied. It is not satisfied. That means what? That is the perfect position to place that queen, sir. Then it will return true. Have you observed how beautifully we implemented is a safe function? Now, if it is returning true, then I will place the queen. I will go for next row. If it is returning false, then what will happen? I will go for next location. I will go for next location, like that. Sir, I placed the queen, but in the next row, this condition is not satisfied. That means what? This task got completed, right? Now what will happen? Pending task is there, right? It will call. Okay, like logically it is going to round up, sir. Logically it is going to round up. I think if you see yesterday class, I explained some condition is there, some condition is there, some condition is there, some condition is there, some condition, until reach here. If it is base case is satisfied, means it will print. Again it will go one step backward. Again it will go one step backward. Again it will go one step backward, and it will look all the possible combinations. This is called as what? Backtracking. Okay, sir, here just I am explaining with one small here. Observe carefully. I got up to this. Next, is there any possibility here? No. Then it will come up here. Sir, is there any possibility? I mean, here we got to fourth row. Then immediately the program is going to terminate. But this is single solution. Sir, what about next solution? It will try to place here. Backtracking means what? Here we got solution, right? So it will move one step backward. So here we place it. Now it will check here. Is there any possibility? Then it will check here. Is there any possibility? Is there any possibility? If there is no possibility, again here we place it. So that one also is going to move here. Backtracking. Again it will place here and it will check. Like what are the possible ways are there? Every possible way it is going to cross check, sir. Okay. Almost you can imagine how many times this tree structure is going to execute. Sir, is the coding is perfect for you people? Please confirm. Clear, friends? Everyone, please respond. Sir, previously you have asked so many doubts. Now you people are not at all giving any response. I mean doubts. There are two reasons. You understood everything. You have not understood anything. Hmm? Rohit, why we check only upward possibility? I'm not understanding. Very simple, Rohit. Listen carefully. See, I have a chessboard like this. What is the first step, sir? What is the first step? We have to check whether the queen possibility is there here or not. Definitely, is a safe function is going to return true. Why? Because there is no queens in the up. There is no queens in the diagonal. There is no queens in the diagonal. So it will return true. Next, once if it is returning true, what will happen? It is going to place the queen. Next, it will jump to row plus one. It won't check for next one. It will jump to row plus one. So we are not required to check here. Okay, leftwards we are not required to check. Listen my points. Sir, total how many positions are there for queen? It can move in up direction. It can move in down direction. So it can move in diagonal. So in diagonal, there are two possibilities. Fourth one, it can move in left direction and it can move in right direction. Sir, now I think right direction we are not required to verify, because once if this condition is satisfied, it will go to the next row. No need to check here. There will not be any queen here. Now, second row, here is there any possibility? Upward we have to check. Okay. Now, sir, I am going to place here. Is there any possibility? Up, up, up. Sir, here, if you have any node, then you can check in the down. But we don't have, right? That's why we have to check only in up. Sir, left checking, already we are going to check whether this queen possibility is there or not. Then only we came to here. So no need to check previous node, because definitely it won't be there. That is the reason why we got to the next one. So here also possibility is not there. Downward possibility is there. So the only possibility is up direction, diagonal, diagonal. So in the down direction, anyway, we will check one by one. Got it? Rohit. Right. Now we have a time to execute this, but I don't know. Definitely there will be n number of errors. Let us clarify. Oh, luckily we don't have any errors. Let us run the program. Sir, these are the two possible combinations that we have, right? These are the two possible combinations, correct? So in the first 0, 1, 0, 1, and then 0, 2. Like this we have. Sir, I want to print the number of possibilities. What we can able to do? Inside this class, let us declare one counter variable. So where we have to increment this counter variable? Sir, whenever we printed that board, yes, here I can increment a counter plus plus. Where I can print result at last. So system dot out dot println of. So number of solutions is nothing but plus counter value is there. Okay, let us run. Sir, I will take only one by one chessboard. How many possibilities will be there, sir? Only one solution. What is that solution? This is the solution which we have. If we have 2 rows and 2 columns, can I place queen here? Yes. What about the next queen? We can't place here. We can't place here. Even if you move this queen to here, you can't place here. You can't place here. There is no solution for this. Okay. There is no solution for this. Now let us see, by taking queen is equal to number of queens is equal to 2. There is no solution. Okay. Sir, can I take a 3 by 3? Sir, 0 solutions. If you want, you can cross check. So 3 by 3 means 3 rows and then 3 columns. First queen. Can I take second queen here? No. Can I take here? No. Can I take here? Yes. Can I take here? No. Can I take here? No. Can I take here? No. So this combination got. Next queen here. Can I take here? No. Can I take here? No. Can I take here? No. Sir, next we can take here. Sir, can I take here? Yes. So next, can I take here? No. Can I take here? No. Can I take here? No. Sir, can I take here? No. Can I take here? No. That's all. All possible combinations got completed. That's why there is no solution. Sir, for 4 by 4 we have seen. Let us check for 5 by 5. How many solutions will be there? I think we got 10 solutions. If you trace out, you will get all the possibilities. Have you observed? First queen here we placed. So second queen, in this chance is there, no chance, in this no chance, here chance is there. But have you observed? Because of backtracking, it is moving this queen to this position also, and it is checking one more solution. Got it? Sir, next one, second. So second row, this position it is checking one condition, this position also it is checking. Sir, third row. So two solutions. Have you observed? So third row, fourth row, like this, it is going to check everywhere, sir. Okay. If you keep on increasing this particular number of rows and columns, then you are going to get those many solutions. Guys, please confirm, is this n queens problem? How we resolved by using this backtracking? Is it clear for everyone? Please respond, everyone. How it is backtracking? Please explain. Ayo. Sir, the entire story is based on backtracking only. Huh? See here. One more time I am explaining. The people who have not understood this backtracking, please listen carefully. Consider I have a 4 by 4 chessboard is there here. This is nothing but 4 by 4 chessboard I have. Just I am talking about backtracking alone. Listen carefully. Let us label this. 0th row. This is row. First row, second row, third row. This is column. 0th column, first column, second column, third column. I passed 0th row. I passed 0th row. Sir, it came here. My pointer is pointing here. J is equal to 0. So J is equal to 0. Now, sir, I am asking, is it safe to place a queen in this row and J? Row value is 0, column value is 0. Is it safe here? Yes, because in the top, we don't have any rows and columns. In the opposite diagonal and main diagonal, we don't have any content. Sir, after placing this, listen carefully. After placing this, it is calling n queens. Okay, first time I am executing. Okay, first time I am executing. So there are two choices are there. It will execute board of assigning the queen and placing x. So after this, which thing will happen? We are calling so board of row plus 1. Sir, we are taking row value as incremented by 1 unit, 1. We will call again n queens. Sir, is this operation is pending or not? Yes. Listen carefully. Now what will happen? Sir, it is going, okay, it is going to check. So next row, is there any possibility here? My is safe function is going to return false. So it won't place here. J value is incremented by 1 unit. Is there any chance of placing here? No, because collision. Sir, is safe function is going to return false. Can I take here? Yes, we can take. Now, sir, what will happen? This is safe function returned true. Now what will happen? It is going to assign the queen here. Then queen got assigned. Then backtracking is there, right? That is nothing but this one. But it is not executed as of now. It is also not executed as of now. Then again, what will happen? It is going to send row 2. Sir, here, can I place? No. Sir, can I place here? No. Can I place here? No. Can I place here? No. Then what will happen? There is no solution here. There is no solution here. Backtrack. Go for next possibility. this possibility is not executed. So where I have to assign X, where we got this problem here. So take this second position as X and increment J value by 1 unit. Now this part will be continued. Got it, Ram? Clear? Ram, please tell me really, is it clarified for you? Yes. Right, sir. This is nothing but how backtracking is going to work. Okay. Sir, I request everyone to please respond. Really, is this backtracking concept got into your mind or not? Because it is a small, simple instruction. That's all. Nothing more than that. You got the solution or not? Right. And some people are going to feel, sir, if you remove this, okay, if you remove this, we will get the solution. No, never. Because after assigning the first queen, we will check next queen possibility. No possibility. So no possibility. So no possibility. Assume there is no possibility for all these. Since there is no backtracking, it will stop here itself. If we have a backtracking, then it will push this queen to the next position and we will check. This is called as backtrack. So this instruction is very important. What is the difference between recursion concept and backtracking? Because even from this diagram, stack trace call would be the same in the recursion also. Yes, in the recursion also, same stack trace will be there. Okay, but in our previous examples, we have not utilized that stack trace after completion of our task. That is the problem what we have. Okay, that is the problem what we have. So that's why we are in this task. One second. Have you observed here in the beginning diagram? I explained this. In the recursion, what will happen? It will maintain this stack trace. Then finally, it is going to add these values. Okay, finally, it is going to add all these values. If you see here, so it will take first value as a 5, next value as a 4, next value as a 3, next value as a 2, next value as a 1. That alone we calculated. But this recursion, that maintained variable also will be there, sir. So that part we didn't discuss it. But these variables will be loaded in this particular stack call or not. I explained very clearly by taking this diagram. If you observe, this diagram full-fledgedly clarify you that particular concept. Got it, Vishal? So internally recursion is using backtracking. That's what I'm telling from the beginning. Recursion, backtracking, both are same. But in the recursion, we will compute only values and we will finish the task. But in the backtracking, the positions will be recalled. So if I write anywhere backtracking, then that entire in that recursion call, whatever content is there, it will maintain internally everything so that it will be useful for backtracking. Got it? Right. Little bit confusion. So no need to go beyond that. Sir, next 2 more applications are there. Let me finish that. Sir, gridways. It is a small problem. Just I need to give this as an extra for you people. We need to find the number of ways to reach from 0, 0 to n minus 1, n minus 1 in a n by n grid matrix. So we have to check how many possible ways are there. But the allowed moves are, what are the allowed moves? You can move in the right direction or you can move in the down direction. These are the only possibilities that we have. I will take one example so that you can understand very clearly. Sir, beginning itself, I am going to simplify the solution. Listen carefully. Assume I have 1 by 1 grid is there. 1 by 1 grid is there. Sir, what is this position? 0, 0. If I want to move from this position to this position, how many moves are required? Only one move. Now assume I have a grid with 2 by 2. I have a grid with 2 by 2. That means 2 rows and 2 columns like this I have. Assume this is the starting position 0, 0. This position is 1, 1. I need to move from here to here. How many possible ways are there? Sir, we have n possible ways. Okay, but the only directions are you can move towards right and you can move towards down. Sir, directly is it possible to move to the diagonal? No. You have to move one step here and you have to move one step here. How many possible ways? One way. Plus, we can move from here to here. Okay, and we can move from here to here. How many possible ways? Only one possible. So total, how many ways are there? Two ways are there to move to this particular grid. Like that, if you have a big grid like this, if you have a big grid like this, assume it is a 4 by 4 grid. Okay, so this is nothing but source point. This is nothing but destination point. I want to move from here to here. How many possible ways are there? We have to find out. The only allowed directions are nothing but these two. For your understanding purpose, so there are probably multiple ways will be there, but just for your example sake, I'm telling. So one or two movements I will explain. Sir, like this we can move, 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 like this we can. One possibility. Sir, can I move like this? Yes. 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 One more possibility. Okay, like that. Sir, now can I move like this? Yes. Can I move like this? Yes. Can I move like this? Yes. Sir, can I move like this? Yes. Sir, can I move like this? Yes. Can I move like this? No. Okay, sir, like this we can move. Sir, this is also one path, right? Which is not same as original. Like this, how many ways are there to reach this? So maybe don't feel that this is a very complex program, but solution will become very easy, sir. Okay, I'm using recursion concept so that a big problem is there, right? So we can divide this into smaller problems. Don't worry at all. Sir, is the problem statement is clear for you people? Is the problem statement is clear for you people? That we will see later, Swapnil. We have so many solutions are there. We need to find how many solutions are there. That is our task. Okay, we are not printing all the possible paths. We are finding how many ways are there. Like in our previous program, how many combinations, how many solutions. Right. Sir, now just to demonstrate this, I am taking a simple 3 by 3, sir. Please listen carefully. If you understand this, everything will become easy. Easy to write the code. Within 2 minutes, I will finish the coding. So because that much easy once if you understand the concept. Now listen carefully. Now listen carefully. Sir, I have this point is there 0, 0. From here, I have to move 2 by 2. How many possible ways are there? Listen my words carefully. First, I will take this one as a small subproblem. Sir, if you have only one, how many ways are there? Only one way, right? Only one way, right? Only one way is there. Okay, right, good. Next, that means if you reach to the last, only one way. Now, my requirement is, sir, if I want to take these two, sir, how many ways will be there? From here to here, from here to here, one possible way is there. Okay, from here to here, one possible way is there. Sir, one. If I want to move from here to here, how many possible ways are there? Only one possible way. That is nothing but one. Sir, now listen carefully. I want to move from this. That means this entire grid I am taking. How many possible ways are there to move from this to this? This is one way, and from here we can go. This is one way, from here I can go. Can I take combination of these two? Two ways are there. So to move from place to place, we have one, and from this one way, from this one way, so that in the top we are going to get how many ways? Two ways. Sir, at least now with this you got some clarity. Can you please confirm? Can you please confirm? Got it? Right. Next, listen carefully. These two addition we got here. Now, sir, from this I am taking. From this I am taking. Okay, from this, how many possibilities will be there? Sir, how many possibilities will be there? In the up, we don't have any option. In the left, we don't have any option. The only option is towards down. So one. From here, down one option, and here one option. Sir, total how many options are there? Two ways. But from here, we have multiple ways. 2 plus 1. 3 ways are there from here to here. If you want, you can see. Sir, just I am explaining at a top level. This is one way. This is another way. Okay. And this is another way. 3 ways are there. Okay, sir. Got it. Now, from here, how many ways are there? Sir, in the down, we don't have any option. Only option is this one. Only one way. From here, how many options? 3 options. What is the first option? Directly to here, down and here, then down, left and then down and then here. One option. So total 3 options are there. Sir, okay, fine. I got clarity. But how many ways will be there from here? As usual, just now we calculated sum of these two. How many ways are there? 6 ways are there. If you want, you can see. This is the first way. This is the second way. Okay. So this is the third way. This is the fourth way. This is the fifth way. This is the sixth way. Like total, how many combinations are there? 6 combinations. Sir, how to get that solution? You people got clarity now, right? Can you please confirm? Is the concept is clear? Right. Now I will implement the program for this. Sir, the task is very simple, sir. I will write a program for this so that you can understand well. Sir, here I am taking number of rows 3, number of columns 3. Sir, system dot out dot println of grid ways. Starting from which location to which location we have to 0, 0 to n, m. Like this I am passing. Okay. Now, what method we have to take? Public static integer function we have to take. I am taking grid ways where I will take integer I, j, starting positions n and then m. Like this I am taking. Now we have to write a base condition. What is the base condition? Boss, if your I value is equal to n minus 1 and your j value is equal to m minus 1, that means I reach to the end. Then we have to return 1, because in the diagram you can see at the end how many possibilities are there? Only 1. Sir, I have not reached to n, so I is equal to n, okay, and j is equal to m. That means what? So I went out of this, at the same time I came out of this. So then what will happen? The task is completed. Then you can return 0 and you can stop. Not and here we have to take r. That means whether you have reached out of this boundary or you came out of this boundary, you are going to return 0. That's all. This is base condition. Now I will take two solutions. Value 1 is equal to value 1 is equal to, I will call gridways by adding I plus 1 comma j comma n comma m. So I am taking value 2 is equal to gridways of, I will keep I value as it is, j plus 1 comma n comma m, like this. Now at last we have to return value 1 plus value 2. Listen carefully how it is going to work. Sir, from here I am executing. Okay, from here I am executing. So is your I value, these conditions are not satisfied, I am calling gridways of I plus 1. I plus 1 means what? 0, 1, 2. So 0, 1, 2. I plus 1 means what? So this is the I value, consider row value. So I plus 1 means next value. This grid sum I am calculating. That means this value. And I value I am keeping as it is, j value. That means this. These two sum values are nothing but this result, right? That is I am calculating. But internally it is a recursion. Again, it will calculate for grid of I plus 1. That means to get this value, how we are getting sum of these two. Again, it will calculate to get this value, sir, sum of this one and this one. This one is 1. What about this one? It is going beyond the remainder. So 0. We got the result. And to get this value, it is calculating this one and this one. To get this value, it is calculating this one and this one, where the stop process is going to stop. Like that, it is calculating. Now let me check whether the code is working properly or not. How many ways are there? 6 ways are there. If I take 4 by 4, sir, how many possible ways are there? Maybe 20 ways are there, sir. If you write diagrammatically, you people will get clarity. Okay, so like this, we can able to find out these grid ways how you can calculate. Can you please confirm, friends? Is the concept is clear for you people? Everyone? Clear? Right. So that's all about today's session. Sir, tomorrow we will complete this backtracking. Last problem we have. So Sudoku problem we are going to solve. Sir, I have a problem in base condition. What is the problem in base condition? Rohit, what is your doubt? Okay, I will explain the base condition one more time. Listen, friends. I am explaining for 2 by 2. I am explaining for 2 by 2. Okay, please listen carefully. 0, 0 I passed. And here we got 2, 2. So this is 0, this is 1, this is 0, this is 1. Sir, first time I passed 0, 0. My I value is 0, j value is 0. How many possible ways are there? Is your I is equal to n minus 1, that is 2. I think here it is 1, 1, right? Sorry. 1, 1. Is I is equal to 1? No. Is j is equal to 1? No. Then is I is equal to 2? No. Is j is equal to 2? No. Then value 1 is equal to grid base of I plus 1. I value got incremented by 1 unit. J value remains same as it is. Then I value is 0. I value is 0. Sir, is it equal to 1? Sorry, I is equal to 1. Is it equal to 1? Yes. And is j value is 1? No, it is not equal. Then, sir, I is equal to, is it n? No. Is j is equal to n? No. Again, what will happen? So it is going to call grid base. Sir, by adding I plus 1. What is I plus 1? 1 plus 1, 2. Sir, 2, 0. Is I value is equal to n minus 1? No. Is j value is equal to m minus 1? No. Sir, if I is equal to 2, yes, I is equal to 2, return 0. This value is going to return 0. Okay. Now, what will happen? Sir, backtracking. Backtracking. J plus 1 we are taking. Okay. Like that, it is going to keep on move, sir. So, when it will return 1, if I is equal to n minus 1, that means in this position or in this position, it will return 1 or in this position. Okay. When it will return 0, when we are moving here, it is going to return 0. Got it? In the remaining places 1. Whatever 1 you are getting, that will be carry forwarded to the next results. Got it? Try to trace out, sir, you will get it clarity. Okay. Now, sir, tomorrow we will solve this pseudocode. Okay. But my sincere request for you people, you have to do some small homework for you people, sir. Can you please tell me how many rows will be there? How many columns will be there in pseudocode? Sudoku. I think you have solved at least 1 or 2 members. How many rows? How many columns? Yes, 9. Oh, not 3 by 3. 9 by 9. 9 rows will be there. 9 columns will be there. Sir, I request everyone. You have to do this task. You need to prepare a 9 by 9 matrix with 9 zeros. 3, 6, 7, 8, 9. 9 zeros are there. 3. So 3, 3. Like this. This is first row, second row, third row, fourth row, fifth row, sixth row, seventh row, eighth row, ninth row. You need to fill this one, sir. You need to fill this one. Sir, take any Sudoku. Try to find out in the internet or try to find out in the newspapers. So you need to have a problem and a solution. Okay, you need to have a problem and a solution. Sir, in the problem, they are going to give only few positions. They are going to give only few positions. And they will ask us to fill this particular Sudoku, sir. Okay, they will ask us to fill this Sudoku. If you want, 1 second, I will show you the program. But of course, I am not executing that program now because I already having this code. 1 second. Of course, it is very simple program. Don't worry. Yes, this is nothing but my Sudoku problem solution, sir. I have this Sudoku is there. Okay. Sir, I want to print this Sudoku. I want to print this Sudoku by calculating the solution. Now I am executing this problem. Listen carefully. Sir, the initial Sudoku which they have given is nothing but this one, sir. The initial Sudoku which they have given is nothing but this one. So in the first row, only one value they have given. In the second row, sir, 3 values they have put it as 0. We need to fill this such that we have some rules. What is that rule? The number which you are taking, it should not be present, it should not be duplicated in the entire row and in the entire column and in the entire grid. What is the grid here we have? This is one grid. This is one grid. This is one grid. This is one more grid. Okay, I think still we have solution. Maybe. So this is one grid. This is one grid. So if you are taking 4, this 4 should not be repeated in this grid. At the same time, it should not be repeated in the column. It should not be repeated in the row. Can you please cross check? Is it similar to n queens problem or not? Can you please confirm? In the place of queen, we have to place the digits. Correct, right? In the place of queen, we have to place the digits. Yes, same problem. So anyway, tomorrow we are going to talk about the discussion. Yes, little bit. So I will do one thing for your understanding purpose. So maybe if time permits for you people, try to trace this program. I will put this solution also in our chart. I mean, in our running notes. Just you can cross check. Okay, how it is going to work. Anyway, tomorrow I will give solution how it is going to work. All these things. Don't worry at all. Okay. I already implemented the problem. So just I am giving the solution in advance. Try to cross check. Okay. Anyway, we will see the solution tomorrow. Clear, friends? Right. So tomorrow we are going to finish this backtracking. And if possible, tomorrow I will start a new topic also. Okay. I'm planning for that. And Wednesday, there won't be any classes, sir, because some festival is there, right? Wednesday, there is no class. And we will continue from Thursday. Okay. Maximum I am trying to finish by this week or next week, 1 or 2 days. Okay. What is the passcode for this patch? I think I don't know, sir. 1 second. Who is asking passcode? Rohit. 1 second, Rohit. 444123 is the passcode. 444123 is the passcode. Right, sir. So thank you. We will meet for the continuation tomorrow, guys. Okay. Right. Thank you, guys. See you tomorrow. Yeah. Good night.